I've been thinking, why do lakes freeze from the top down?
We are here to figure it out.
Why do lakes freeze from the top down? This is our table of contents.
What chemical reactions or processes are involved? Freezing and crystal formation in solid involving with density. Freezing occurs after the general lake water has cooled and then the temperature of the surface water drops below 4 degrees Celsius, causing its density to decrease, so this cooler water remains at the surface. Then the ice layer, which is less dense than liquid water, forms. Crystal formation results in a solid characterized by a unit cell and its extension in 3 dimensions. Each sphere represents an atom, ion, or molecule and is called lattice point. Ping pong balls are one example that can visualize how particles might form an ordered 3-dimensional structure. The way these spheres are arranged in layers determine the type of unit cell.
Temperature decreases. When the temperature drops below 0 degrees Celsius, liquid water freezes to form ice. H2O liquid forms into H2O solid. This is the physical change. Energy is released during this process as latent heat. Water molecules lose kinetic energy and arrange into a crystalline lattice. Advantages: preservation of food, climate regulation, ecosystem support, energy storage, and water resources management. Next is the disadvantages: damage to infrastructure, hazards in transportation, crop damage, energy usage, and impact on aquatic life.
Temperature increases. When the temperature rises above 0 degrees Celsius, ice melts into liquid water. H2O solid forms into H2O liquid. It's a physical change. Energy is absorbed during this process as latent heat. The crystalline lattice of the ice breaks down into freely moving water molecules. Advantages: hydrological cycle, climate buffer, glacial retreat studies, and adaptive technology. For the disadvantages are rising sea levels, loss of albedo effect, water management challenges, disruption to ecosystems, and freshwater scarcity.
What are the benefits and or risks associated with these processes? Benefits: create material with specific properties. Ice has highly ordered 3D structure where water molecules are held apart by hydrogen bond forming an open lattice. When ice melts, some hydrogen bond breaks, allowing molecules to move closer together, increasing density.
Risk: ice and snow block sunlight, reducing photosynthesis by aquatic plants and algae, which lower oxygen level. Prolonged ice cover can cause dangerously low oxygen, threatening fish and other aquatic organisms. Shorter or delayed ice seasons due to climate change can warm lakes earlier, promoting harmful algae blooms and invasive species growth, disrupting the ecosystem.
How do these processes affect people or the environment? This allows aquatic life to be able to live in the non-frozen, still liquid 4 degrees Celsius temperatures at the bottom of the lake all winter. As it cools further towards freezing 0 degrees Celsius, which it becomes less dense, then rise to the surface and wait for the spring to come. Wild land animals can live above the ice layers normally, such as human and polar bears.
Effect on environment: protect aquatic life, maintains ecosystem stability, and slow evaporation.
Effect on people: enables winter activities, prevent water supply disruption, and influences climate regulation.
Real-world application: monitoring ice thickness for human safety and winter sport because people often walk, skate, or ice fish on the frozen surface. Understanding how and when ice forms help determine when it's safe to go out.
Our global warming affects the ice. Disrupt fish hibernation and lower oxygen levels. Lakes are freezing later in the year and melting earlier. This means ice layers are thinner and don't last as long, allowing cold air to reach deeper water layers.
Fun fact: certain fish in icy lakes create antifreeze proteins that prevent their blood from freezing, allowing them to survive under the ice all winter. Lake Baikal in Russia, the world's deepest freshwater lake, freezes over completely each winter. Its ice can be up to 2 meters thick and crystal clear.
A summary: when water freezes below 0 degrees Celsius, it forms ice with a crystal structure. Ice is less dense than water because of the way the water molecules arrange themselves when they freeze, so it floats and creates a layer that insulates the water below, helping fish and other aquatic life survive in winter. Crystal also forms in solids when atoms or molecules arrange in patterns which can affect the strength and properties of materials.
Freezing has many benefits, like preserving food, regulating temperature, and protecting ecosystems. However, it can also cause problems such as broken pipes, slippery roads, low oxygen in water, and rising sea levels when glaciers melt. Understanding freezing and crystal formation helps us use these processes safely and effectively.
Now I understand why